Hello, good morning, students. Today we are going to solve a problem on the relationship between equilibrium constant K and that is reaction constant Q and Gibbs free energy. So let us have a look over it, student. How can you be able to solve the problem on it? So that is the relation mathematical expression for the thermodynamics view of equilibrium expressed by want of isotherm equation. So want of isotherm equation is what was there, student? Delta G is equal to delta G naught plus RT ln Q, where delta G is stand for Gibbs free energy. At equilibrium, we know that is delta G is equal to 0 and Q is equal to K. Okay, so what we have to do, that is we have to simply put the value delta G is equal to delta G naught plus RT ln Q. So at the place of delta G, you are putting 0 equal to delta G naught plus RT ln. At the K place of Q, we are putting that is K. So that we can write that is delta G not is equal to RT ln K, or delta G not is equal to RT ln K. So this is the relation and this will be the negative sign, student. Now if you are putting the ln into log, so we have to multiply with the conversion factor. So delta G naught is equal to minus 2.303 RT log K. This term is coming. If delta G is less than 0, if delta G is less than the 0, that is negative, then minus delta G naught upon RT is positive, and e power delta D naught upon RT greater than 1, making K greater than 1, which implies that spontaneous reaction or the reaction which proceed in the forward direction to such a extent that the product are the present predominantly, and if the delta G is the greater than 1, which implies that the non-spontaneous reaction, a reaction which proceed in the forward direction to such a small degree that only a very minute quantity of product is formed. So at equilibrium delta G is 0, but delta G naught may be 0 or positive or negative. The standard free energy of the reaction at 298 Kelvin is minus 125.52 kilojoule per mole. Calculate the equilibrium constant Kp. Okay, so this is the question, student, where we have to calculate the Kp. The standard free energy, standard means G naught. Free energy of the reaction is how much is there? Minus 125.52 kilojoule per mole. Okay, kilojoule per mole. So they are saying calculate the equilibrium constant Kp. They are asking, student, Kp. So we know, a student, from the want of equation. Okay, from we can, I'm writing that is from want of equation. So want of equation was there, student. Delta G is equal to delta G naught plus RT ln Q. So we can replace this by equilibrium constant. At equilibrium, what we can write, student? See, at equilibrium delta G is equal to 0 and Q is equal to Kp. So we can imply that 0 is equal to delta G naught plus RT ln Kp. So that is delta G naught is equal to minus RT ln Kp. So what we can put ln into log. So delta G naught is equal to minus 2.303, okay, RT log, what will come, student? Kp. Right, in this equation they are asking Kp, student. So let us put the value firstly, student. What is the log Kp is equal to? What can we write, student? Log Kp is equal to, these are all the multiple in the form of multiplication. So minus delta G naught is equal to, what we can write, student? Minus delta G naught upon 2.303 RT. Okay, put out the value, student. So delta G value here is kilojoule. They have given convert into joule. So it is coming minus, and it will be also negative sign. Okay, because the value is given in the negative. See here. So negative, how much is there, student? 1,25520 divided by 2.303 into 8.314 into 298. Okay, so minus into minus, this will come. So 1,25520 divided by how much is coming, if you are simply multiplying this. So here, wait student, we are doing the calculation in detail also. Let me check the calculator, students. So 2.303 multiply by 8.314 multiply by 298. So it is coming, student, 5705848.3, and this is coming equal to log kp, right? So if you solve it out, student, let me see it, how much the value is coming. 1,25520 divided by 570584.8.3. So it is coming, student, log kp is equal to, it is coming 0.9985, right? Up kp is equal to, this log will go that side, so it will come nt log, how much? 0.9985. so this value nt log, right? So how much value is coming, student? Value is coming this, if you are simply adding, so kp is equal to coming, student, 21. Okay, kp will come 9.965 multiply by 10 power minus 21. This will be the kp value. This is the mathematical terms, student, which we have to understand. Next question, you see, student, what is the next question? They are saying for the reaction H2 plus I2, it is giving 2HI, and Gibbs free G delta G is positive. The equilibrium constant K would be, okay. So dear student, how you can be able to solve? So delta G is equal to, delta G is equal to what is the relation, student? Minus RT, okay, ln kc, this is the equilibrium. Now student, delta G not greater than 0, okay, delta G not greater than 0 means delta G is positive, means delta G not is equal to positive. If delta G is positive, student, this can be only if Kc is negative. This can be only if Kc is negative. Kc is negative. Why, student? Because this is the negative term is there, and we have to be get negative, so negative positive will come. So that is Kc will be negative. So at the so Kc is negative and delta is the positive. So that is Kc is less than 1. So what they are asking, the equilibrium constant Kc is less than 1. So option number 4 is correct, student. Kc is less than 1. Let us have a look over the next problem, student. What is the next problem? Which of the following options will be correct for the stage of half completion of A to B? Delta G not equal to 0, delta G not less than 0, delta G is more than 0, and delta G not is equal to minus RT ln Kc. Okay, so which of the following option will be correct for the stage of half completion of the reaction A and B? So student, for half completion of the reaction they are asking. So we know student, we know what is the delta G naught is equal to minus RT ln Kc. Okay, at the stage of half completion of the reaction, what we can write student, half completion, if you are writing half completion, that is, we can write that is equilibrium constant, equilibrium condition. So that is A, reversibly B. So if the at the half concentration you are writing, so concentration of A equal to concentration of B, concentration of A is equal to concentration of B. It means K is equal to, it means K is equal to 1, K is equal to 1, that is equilibrium condition, equilibrium constant, equilibrium. Up now, if K is equal to 1, so let us have a look over the delta G value is equal to. Delta G is equal to minus RT ln, we are having K. So delta G naught is equal to minus RT ln K value. K value how much is there student? 1. So K value is 1 student. Okay, so ln 1 is equal to 0. ln 1 is equal to 0. So delta G naught is equal to minus RT ln 1 is equal to 0, multiply by 0. So delta G naught is equal to, it will come 0. So delta, which could be the correct answer? Option number A is correct. Delta G naught is equal to 0. So this is all about the relationship between equilibrium constant, reaction constant and Gibbs free energy. Thank you so much for watching, dear student.